Let's go back to our creating linear functions handout, and let's look now at example 5. Example 5 says, Davis Printing finds that the unit cost of printing a specific book is $12.65. Okay, let's put that information down here on the board. So the unit cost is $12.65. The total cost of printing 2,700 copies of the book, okay, so one printing, they made 2,700 copies of the book, and that was a cost of $36,295. Find the linear cost function that relates number of copies printed to the cost of printing. So we want to create a linear cost function. Well, let's call it C of x. So if it's a linear cost function, then it has to take this form. C of x equals mx plus b, where x is going to represent the number of copies of the book that we make. Well, the unit cost, that's dollars per copy of the book, isn't it? Isn't that our slope? Change of y, the y is cost, change of cost over change of x. X is the number of copies. Cost per copy, that's what we have right there, $12.65. So I immediately know that, well, let's just do it this way. I immediately know that my slope is $12.65. That was given to me in the problem as a cost per copy to print the book. So now I just need to find the b value. Well, they didn't give me the fixed cost. Remember, that's what b is in a cost function, the fixed cost. But they did tell me that when they printed 2,700 books, the cost was $36,295. Well, can't I use the 2,700 for the x value and the $36,295 for the cost value? Oops. And create this linear equation in one variable that I can solve? And if I solve that equation, I find that b equals, what's my b value here? B equals 2140. When we solve that equation for b, we get b equals 2140. So that's our fixed cost. Whether we make no books or 100 books or 1,000 books, we still have $2,140 of fixed costs for our manufacturing, our printing process. So there's my cost function. There's my linear cost function. Also sometimes called a linear cost volume function. You'll see that terminology as well. Now it says Davis Printing plans to sell the book for $17.95. They're going to sell the book for $17.95. Well, doesn't that immediately enable me to write this revenue function? If they're going to sell the book for $17.95, wouldn't that express the revenue function? And then the question was, how many books do they need to print and sell to break even? Break even is where revenue equals cost. It's where 1795x is enough to equal out 1265 times that same x value, number of books, plus 2140. There's a certain number of books that if I sell them at $17.95, it will cover having printed them. And we have that linear equation that we can solve. Well, if we subtract 17 and 6500x from both sides, that's going to give us, 12 and 6500ths. That would give us 5 and 30/100ths x, right? Equals 2140. If I did my subtracting correctly. And if we divide both sides by 5.3, 2140 divided by 5.3 gives us 403.77. So they're going to have to print at least, what, 404 books, 403.77. You get X equals 403.77. Well, you can't print 77/100ths of a book. So aren't they going to have to print 404 books to break even? So in order to perform this break-even analysis, we first of all had to take the given information and construct our cost function and our revenue function. Then we could perform the break-even analysis to find the answer.